So, this is the Mux lab. This is the 2Mux module. There's input 0, input 1, input select, and the output, out 1. And I'll explain why that's out 1 later. So, here's the first one. I used an always block, and it's bringing in 1, in 0, and select. Case using select. 0, out 1 is in 1, 1, out 1 is in 2. If 0, out 1 is in 0. If 1, out 1 is 1, in 1. And the default is this. 1. And that's it. I commented out this, because this is basically the same thing, and the lab wanted us to do it. But I found this one was smaller and easier to comprehend at a quick glance than 4Mux. So a 4Mux is 3 2Muxes. So a mux that takes in 2 inputs and select, and then has an output, and then another 2Mux that takes in the other 2 inputs and the same select, and then again an output, and then a 2Mux that takes the output of the previous 2Mux, 2Mux, and the other select, and then outputs the out. And I used out 2 here. Same with the out 1 at the 2Mux, out 2 here. Yeah. And then the 8Mux, you can see I used out 3. And I also used select 1 and select 2. Yeah. I probably could have done this better, but I didn't. Oops. But anyway, for an 8Mux, you need 2 4Muxes, which are themselves 3 2Mux, and a 2Mux. So in total, you're using 7 2Muxes. And I used M0 to M7 for the inputs. And for the first 4Mux, you want to use M0 to M3, so the first 4 inputs, and then the first select of the 3 selects, and the second select. And then you've got your output. Well, your first output. And then for your second one, you want to use the last 4 inputs, so M4 to M7. And then you want to use the same selects, that is select 0 and select 1 in this case, or 2, 0 and 2, 1. And then you've got your second output, which I've called O1 and O2. And then you've got your 2Mux, which takes the outputs of both 4Muxes and puts it into 1, so you get a 8 to 1. And for this one, I've got the output O1, which is the output of the first 4Mux, O2, which is the second 4Mux, select 2, which is the last select option, and then out 3, which is just the output. And so that's the guts of the code, as it were. And then the test bench. So, yeah. I know that there's a way to essentially have it set up as like 0 or bracket 7:0 bracket D, and that could essentially do the D0 to D7, but I didn't quite know how to actually implement that down here that way, so I did it this way. So yeah, D0 to D7, S1 to S0 to S2, that would be select. Same with the D's are the inputs, and then Y is the output. So here's the 8 mux, UUT, the inputs, the selects, the output. Then I had 2 for loops going, because putting them all in would be a lot. Like, an insane number of a lot. So I just kind of set up a double for loop, which you can see it all here. So you start, and then for I is less than 8, starting at 0, so I could have done less than equal to 7, but less than 8 works, and then it increases by 1. And then you got your select 0, or select 2, 1, and 0 equals I. Since I goes up to 8, that's 3 digits, or 3 binary numbers, so 1, 2, and 4, which is how it's how I look at it to make it easier to understand. And then J. I use this number because I just plugged it into a calculator. 2 to the 8th power, 7th power? One of those. I plugged it into a calculator and got that number. And when I ran it through the test bench, when I ran the simulation, it came out right. But yeah, no. Since J goes up to a much higher number, you can have a much larger setup. So simulation.
Oh, I know. Oh my gosh, my freshman. Yeah. I had one parent and son, both emailing me, repeatedly asking me to grade work from Unit 1 when the deadline for late work had already passed. Kept asking and asking. I kept saying
There
no,
we go.
and I was like, dude, I don't know what to tell you. Like, it's not, my answer isn't going to change. It's no.
So yeah, 0 and select 0. So 0, 0, and then the output follows this one, and then for 1, the output follows this, and then over here it's 2, so it goes to this line, 3, this line, 4, so on and so forth, with the output being here. You can see as it progresses. And that's the lab.